Hello students, we'll continue with module 4. So in the previous class, we have gone through the basic structure of pneumatic system and about the choice of working medium, which system you have to choose depending on the type of working medium which you use in fluid power systems, whether to use pneumatic systems or hydraulic systems. So in today's class, we'll look into different advantages and disadvantages of compressed air which is used in pneumatic systems. So along with that, we'll go through the perfect gas laws, which you have already studied this in your PU, that is in chemistry. So we'll go through that in brief, not in detail, but in brief we'll go through that. And I'll show you a video on air compressor. So that is what we'll go through in today's class. So let's start with advantages of compressed air. So when in the exam, if they ask you to write about different characteristics of compressed air, you have to write the same, that is with respect to advantages only. So these are some of the advantages of compressed air which is used in pneumatic systems. So since air is available in abundance, so wherever you go, air is available to you. Okay. So air can be transported from the source of point to the point of utilization very conveniently through piping layout, and there are no limitations on the distance. So since air is available to you in abundance at any location, so it can be transported from a particular source of point to a convenient location through piping without the limitations of distance of transportation. So compressed air can be stored conveniently in reservoir and used whenever required. You can store the compressed air. Once the air is compressed, you can store it in a reservoir and can use it whenever you require the use of compressed air. So compressed air is free from explosion and electrical hazard problems. So compressed air, since the air is easily available, so it is naturally available, so it will be free from explosion. There are no additional chemicals as it is in case of hydraulic fluids, so it is free from explosion and electrical hazard problems. So air is clean and has no leakage or messy problems like hydraulic fluids. So since air is clean, if you are using air, there will be no problem of leakage, as you might find out in hydraulic systems. So generally, temperature variations do not affect the performance of air systems as long as good air treatments such as filter, regulator, and lubricator, okay, are maintained. Okay. And most of the components of air system are simple and compact in design. In the first slide itself, you might have seen a simple pneumatic system to control the actuator. So see the size of a hydraulic system and see the size of the pneumatic system. So pneumatic systems are simple and compact in design when compared to hydraulic systems. So these are some of the advantages of compressed air. So I'll just go through that once again. So available of air is abundance in all locations. So air can be transported from one source of point to other source of point without any limitations on the distance. So it can be stored conveniently in a reservoir and can be used whenever required. This air is free from explosion and there are no electrical hazard problems. Air is clean and has no leakage or messy problems as in case of hydraulic fluids. So there are no temperature variations. So temperature variation do not affect the performance of air systems. If there are temperature variations in case of hydraulic systems, it might affect the system performance, but not here in case of pneumatic systems. So temperature variations do not affect the performance of the air. So one more thing, you can see as long as good air treatment systems are available. So whenever you use air in the pneumatic system, make sure it is filtered and then used in the pneumatic systems. And these pneumatic systems are simple and compact in design. These are some of the advantages of compressed or characteristics of compressed air. So next is disadvantages of compressed air or disadvantages of pneumatic systems. So these are some of the disadvantages of compressed air. First one is power. So air as a working medium is not useful for high power and high precision applications since it is compressible in nature. So since air is compressible in nature, so these pneumatic systems cannot be used for high precision and high power applications, which we have discussed during choice of working medium in the previous class. So next disadvantages about lubrication. So air is not a good lubricating medium like the hydraulic fluid. So hydraulic fluids act as a good lubricating medium for hydraulic systems, whereas that is not the case for pneumatic systems. So air cannot be a good lubricating medium. So next disadvantage is regarding heat dissipation. So air due to its low conductivity cannot dissipate heat as much as a hydraulic fluid. So due to the low conductivity of air, so dissipation of heat is lower for pneumatic systems when you compare it with hydraulic systems. So next disadvantage is sealing. So air cannot seal the fine gaps between the moving parts unlike the hydraulic fluids. So hydraulic fluid can seal the fine gaps which are present between the moving parts, whereas if air is used, so it cannot seal the fine gaps which are present between the two moving parts in the pneumatic systems. So in the last disadvantages regarding noise and condensation. Air as a working medium is always noisy and is prone to severe condensation problems with temperature variations. So since air is the working medium, your pneumatic systems are always noisy, and these are mainly prone to severe condensation problems if there are any temperature variations in the systems. So these are some of the disadvantages of compressed air. So first one is regarding power. I'll just go through it once again. So power, if you require high power and high precision applications, if you have high power and high precision applications, you cannot use pneumatic systems because since air is compressible in nature, compressed air cannot be used in the hydraulic systems. Okay, so only for low power and low precision applications you can use air as the working medium. And regarding lubrication, so air is not a good lubricating medium, as when you compare it with hydraulic fluids, they act as a good lubricating agents, hydraulic fluids. So heat dissipation, because of low conductivity of air, so heat dissipation in case of pneumatic systems is lower when you compare it with hydraulic systems. And regarding sealing, so air cannot seal the fine gaps which is present between the moving parts. There will be small gaps in the moving parts. So if air is used as a working medium, so air cannot fill that gap which is present between the moving parts. So but if a hydraulic fluid is used, so it seals the gap which is present between the moving parts. And lastly, noise and condensation. So if air is the working medium, so your pneumatic systems are always noisy. When you compare it with the hydraulic system, they are lower, they'll not don't make much noise. So here pneumatic systems are always noisy and are mainly prone to severe condensation problems if there are any temperature variations in the system. So this is about advantages and disadvantages of compressed air. Now next we'll move on to perfect gas laws. So this perfect gas laws is not there in your syllabus, but even though you should know about these, because since air and gas is used in the pneumatic systems, so this gas or air mainly works on these laws only. So these you have already studied in your PU level, so we'll not go through these in detail, but we'll just brief out the definitions of all these laws in today's class. So if so these laws are determined by the interaction of if there is an interaction of temperature, pressure and volume of a gas in a system, so these are called as, if there is interaction between these three in the systems, so these are called as perfect gas laws. So since perfect gases does not exist in nature, so but their behavior is closely predicted by following these laws. So Boyles law, Charles law, Gay-Lussac's law and general gas law. So let's study about these one by one. What is Boyles law, what is Charles law, what is Gay-Lussac's law and what is general gas law. Now let's see what is Boyles law. So Boyle's law is defined as, if a temperature of a gas is held constant, the volume of the gas will change inversely with the absolute pressure of the gas. So equation for Boyle's law is given by V1 upon V2 equal to P1 upon P2. You can see a small example of Boyle's law with a piston cylinder arrangement. So all other laws also will go through the same examples. So you can see in both the diagrams, so temperature T1 and T2 are being kept constant. T1 will be equal to T2 in both the cases. So at this constant temperature, so force is being increased from F1 to F2. So when a force is increased from F1 to F2, so at constant temperature you are compressing the air. So volume will decrease from V1 to V2 and pressure will increase from P1 to P2. So at constant temperature the volume of a gas will change inversely to the absolute pressure of the gas. You can see volume decreases whereas pressure increases. So this is about Boyle's law, where temperature is kept constant, other two parameters vary inversely. So next one is Charles law. So as in case of Boyle's law, temperature was kept constant. Now in case of Charles law, pressure of the gas is held constant. So when this pressure of a gas is held constant, the volume of the gas or volume of the air will change in direct proportional to the absolute temperature of the gas. So equation of Charles law is been given by V1 upon V2 equal to T1 upon T2. You can see again by taking a similar example. So you can see the two figures. So pressure, you can see the pressure gauge indicator P1 and P2 are same. So in the second case, so this piston cylinder arrangement is heated. So when temperature is increased from T1 to T2, you can see the temperature is indicated in the thermometer. So temperature is increased from T1 to T2. So volume will increase from V1 to V2. So we call this as constant pressure heat addition. So we are adding the heat by keeping the pressure constant. So if temperature increases, volume also will increase at constant pressure. So this is about Charles law. So next law is Gay-Lussac's law. So in the previous two cases, temperature and pressure were kept constant. So in this case, the volume of the gas is held constant. So if the volume of the gas is held constant, the pressure exerted by the gas is directly proportional to its absolute temperature. And the expression for Gay-Lussac's law is P1 by P2 equal to T1 upon T2. So we call this Gay-Lussac's law as constant volume heat addition. Okay, in the previous one it was constant pressure heat addition. So here also you can see there is no piston, but the cylinder is enclosed and the volume has been kept constant, that is V1 is equal to V2. When there is heat added to the system, temperature will increase from T1 to T2 and pressure will increase from P1 to P2. So this is about Gay-Lussac's law, which is nothing but constant volume heat addition. So these are the three main perfect gas laws. So your pneumatic systems mainly work on these laws. If there is any variation in temperature, pressure or volume, either it may work with respect to Boyle's law or Charles law or Gay-Lussac's law. So lastly, general gas law. So when all these laws, Boyle's law, Charles law and Gay-Lussac's law, are combined into a single general gas law or ideal gas law. So expression is given by P1 V1 upon T1 equal to P2 V2 upon T2. So if any of the parameter is kept constant, if pressure is kept constant, it will work as Charles law. If temperature is kept constant, it will work as Boyle's law. If volume is kept constant, it will work as Gay-Lussac's law. So this is about perfect gas laws. So in today's class, we have gone through advantages of compressed air, disadvantages of compressed air. So advantages of compressed air are nothing but the characteristics of compressed air. and about different gas laws, Boyles Law, Charles Law, Gaylos Law, and General Gas Law. So from next class onwards, we'll start with fluid conditioner.